Hi, welcome to Regents Chemistry Review. I'm Mr. B. During this lesson, I will review acid-base titrations. An acid-base titration is actually a neutralization reaction where a certain concentration of acid and base solutions are mixed until the pH of the final solution is close to neutral or 7.0. Remember that molarity is a measure of concentration and is expressed numerically as the following relationship, where molarity, capital N, is equal to moles of solute divided by liters of solution. A burette containing an unknown concentration of acid or base is titrated or neutralized with a known concentration of an acid or base, which is called a standard solution. The volume of the unknown solution is then recorded and used to determine the unknown concentration of the acid or base solution by using the titration formula. Ma times Va is equal to Mb times Vb. When performing a titration experiment, an indicator, usually phenolphthalein, is used. When the acid-base mixture is neutral, the phenolphthalein will turn slightly pink and will represent the endpoint. The endpoint is the point of neutralization in a titration experiment. At the endpoint, the total number of moles of acid will be equal to the total number of moles of base. And at the endpoint, the pH of the solution should be very close to 7.0. When performing titration experiments in the laboratory, use a burette system. The burette system is used to deliver exact amounts of acid or base during a titration experiment. The indicator, phenolphthalein, is often used to determine the endpoint, which represents a neutral solution. During an acid-base titration, a few drops of phenolphthalein is added to an exact volume of known concentration of acid, which is called a standard solution. The standard solution is then titrated with an unknown concentration of base. At the endpoint, the phenolphthalein in solution will have a slight pink color. The volume of the base is then recorded, and the equality MAVA is equal to MBVB is used to determine the concentration of the base. The solution will actually be slightly basic, which is unavoidable due to phenolphtalene's pH range. Because the titration ends when the solution is slightly pink, the pH of the solution will actually be 8.2, where the concentration of H plus ions will be around 1 times 10 to the minus 8 moles per liter. Now for some Regents practice. The following question was taken from an actual Regents chemistry examination. If 5.0 milliliters of 0.20 molar HCl solution is required to neutralize exactly 10 milliliters of sodium hydroxide NaOH, what is the concentration of the base? First, notice that the volume of the base is written as 10 point. This means that this measurement has exactly two significant figures. Therefore, the volume of the base will be exactly 10 milliliters. The choices are number 1, 0.10 molar, number 2, 0.20 molar, number 3, 0.30 molar, or number 4, 0.40 molar. Notice that the volume and the molarity of the acid are written relatively close together in the question. I'll explain the significance of this arrangement a little later. But from the information, the molarity of the acid is 0.20 molar, and the volume of the acid is 5.0 milliliters. Notice that These variables are actually written on the same side of the titration formula. This arrangement is common for titration questions on a Regents examination, and in fact, you should look for this arrangement in order to understand how to answer the question properly. From the information, the molarity of the base is unknown, and the volume of the base is 10 milliliters. Once again, this measurement contains exactly 2 sig figs. After inserting the information into the formula, the molarity of the base is easily determined by simply multiplying 0.2 molar times 5.0 mLs divided by 10 milliliters. And the correct answer to the question will be number 1, 0.10 molar. Okay, one more practice problem, then we're done. The following question was also taken from an actual Regents chemistry examination. In a titration, the endpoint of a neutralization reaction was reached when 37.6 milliliters of HCl solution was added to 17.3 milliliters of 0.250 molar NaOH solution. What was the molarity of the HCl solution? Notice yet again that the information, in this case the information for the base, are written relatively close together in the practice problem. You should remember this for the Regents examination. At any rate, the choices are number 1, 0.115 molar, number 2, 0.250 molar, number 3, 0.203 molar, or number 4, 0.543 molar. From the information, the molarity of the acid is unknown, and the volume of the acid is 37.6 milliliters. And from the information, the molarity of the base is 0.250 molar, and the volume of the base will be 17.3 milliliters. Yet again, I must emphasize, these measurements are written relatively close together in the question and are on the same side of the titration formula. Now inserting the information. The molarity of the acid is unknown, so we multiply Ma times 37.6 milliliters, which will equal 0.250 molar for the base times 17.3 milliliters of the base. So the molarity of the acid may be determined by first multiplying 0.250 molar times 17.3 milliliters divided by 37.6 milliliters, where the milliliters will obviously cancel out. And the final answer, or the calculated result, will be 0.115 molar, which represents choice 1. Okay, this concludes my explanation of how to perform titration calculations, and in fact, a review of acid-base titration. Hopefully, this lesson has been helpful. And remember, should you require more assistance, feel free to visit my Facebook page at facebook.com/WPHS Chemistry. Thanks for watching, and good luck on your upcoming examination. I know you'll do well.